Hey, good morning, Daniel. How's it going?
Good morning, Evan. This is one of our first morning podcasts in a while. So I'm up. I still have coffee with me. I hope that's okay. My coffee cup is the Steamtown National Historic Site coffee. So it has like different symbols that like train workers would like say, like, is this town safe or there's a dog? So
Uh,
that's what I'm drinking out of this morning. How you doing?
I'm okay. It's very early on the West Coast. It's 6:30, so I too have coffee. Mine is a unicorn doing a dab. Yeah, no, sure people watching will be able to see it. Yeah, so I'm excited for today's episode. We are all the way on to episode 11. We are getting a closer look on how oh God, I always butcher this. Generative AI and how it's gonna impact revenue cycles. So I'm sure I butchered that. Our guest will fix it here in a minute. All right. So
Uh, should we just jump straight in?
I think so. It's real early. Let's just rock and roll.
All right, so I get to introduce our guest today. Um, just give a little bit of background. Passionate about the power of data, statistics, and machine learning to solve problems in healthcare and make it easier for providers to care for patients. And so before their current position with Janus, worked at Ancora Medical using machine learning to provide decision support for oncologists and generate real world data supporting clinical trials. Currently the director of data science with Janus. Pleasure to welcome you, Chris Ahern. Thanks for joining us.
Hey guys, thanks for getting up early. I appreciate that. And thanks for having me.
Yeah, no, happy to get up early. I'm usually up, just not fully functioning at this hour.
Yeah, fair.
All right. Well, we thought for using our hot topic segment here, we get some background and re-level our listeners on uh, anything that around machine learning and kind of what it is and how people are kind of using it in the revenue cycle and healthcare space today.
Yeah, so maybe what I'll start with is kind of, what is machine learning? Kind of what are the different kinds of, things we can do with it? And then talk a little bit about, what Janus is doing with machine learning. And I think later on we'll talk about, generative AI. So that's a hard word to say, but we'll kind of get into what that actually means and how it can and probably can't be used, and sort of ways to think about how we apply that. So to kind of take it from a high level, what is machine learning? It's a set of tools and techniques that are used to kind of learn things from data. And that's pretty generic. So if we take that down a level, there's kind of, generally speaking, two kinds of machine learning. One is called unsupervised learning, and the other is called supervised learning. So in unsupervised learning, you have a lot of data, but you don't really know the ground truth, right? You're trying to discover patterns and find things out about the data. So it's a little bit more exploratory. So an example might be if you have a large data set and you do some kind of like clustering, right? You say, what are the patterns in this data? And then can I interpret them further? The other kind of machine learning, or sort of the other paradigm, is supervised learning. And we can think of like two key examples of this. One is regression. So this is where you're trying to kind of learn the relationship between, certain aspects of data and some continuous output. And the other is classification, where you're looking at like features and you're trying to predict a class. So examples of this would be, if you ever had, outcome data that was like a dollar amount you're trying to predict. And if you ever just sort of plotted, um, certain features and sort of the outcome you're like the dollar amount you're trying to get at, and trying to understand. And you said, could I draw a line through those, right? So if you've made that plot, that's just kind of like a simple form of regression. If you've ever been trying to understand, how things fall into different kinds of buckets or classes, that's classification, right? So generally speaking, for supervised learning, what you'll do is you'll take a large data set, if you have it, and sort of the ground truth that you're trying to predict. And you'll give that to a particular algorithm that trains a model to kind of learn sort of from inputs, learn a function to outputs. So maybe let's take like a more concrete example of this. Like an everyday example would be like, let's say you don't, a little bit contrived, but you can't look at your phone and you want to know like, is it going to rain today? Well, you'd look outside, you'd maybe step outside and feel the weather, see if it feels humid, and then you'd make a decision about, whether it's going to rain or not, right? You could think of, meteorologists have, way more data, they can see further, they have lots of more measurements and bigger models that actually predict whether it's going to rain and where it's going to rain. So that's a kind of an everyday example of, how data and models can help you, decide whether to bring an umbrella. Moving to the context of the revenue cycle, let's say you're trying to decide, what account should I work today, right? If you're trying to predict sort of the value of those accounts, you can kind of look at the different features of them. You could say, what's the outstanding amount? Has this been denied? Are there reasons it's been denied? And try to sort of prioritize based on that. Or you can use a model to predict, what's the amount I'm going to be paid if I work this, right? And you can factor in many, many more features, help that kind of drive how you prioritize that work. So that in both those scenarios, that's sort of like a supervised learning paradigm. And that's sort of one way in which machine learning can be applied to the revenue cycle. I'll pause there and answer any questions you guys have. Or I can kind of shift. That's like a nice transition into sort of how Janus is using machine learning in the revenue cycle.
How is it that's, from a standpoint of somebody new, right? So if I'm coming to say, hey, I want to learn more about how the algorithm's going to work. So I know, like, for instance, in Epic, we have work queue scoring, and that score is basically what creates the algorithm, is my understanding, high level, to say, okay, for these accounts, it's going to populate and tell my follow-up teams to do this first and then this account second and that. So is that essentially the same, but we're just taking this now to a bigger component and saying, okay, well, we're taking all of these different aspects versus just appending a score to it, but we're going to also look at timely filing and all these other components and then kick out a new output.
Yeah, so there's a couple ways to think about that. So one of them is sort of like how that model is created, right? Whether it's sort of expertise driven with a little bit of data input, purely data driven. So you're training a model to predict this. We're going to do this automatically over time. And that's actually another important point. So, building sort of implementing a scoring algorithm in Epic isn't necessarily dynamic, right? You configure it and you can tweak it over time, but there still is that configuration versus gathering data over time, being able to retrain a model, redeploy a model that sort of learns over time and is able to do that automatically. But yeah, it's a similar component. So the same kind of way of providing a score and ordering things based on a score is exactly the same idea. It's sort of a question of, where does that model or scoring algorithm come from? How does it change over time? Those are the key differences.
Perfect. Okay.
I'm just trying to like think about like the robustness of like a model. So like if I'm like an organization, I want to get plugged in and maybe I have like a use case or two that I could see there being value. Is that something that like I can take this model and just like apply it to the use case I want, or are these models like structured and needing to be formed like organization by organization, or just like plugged into like a specific use case that's been like pre-configured? Like how do I think about that, and how do I get plugged in?
Oh, yeah. So there's a kind of a question of like, are these if you are trying to tackle this, from scratch, the kinds of models that exist are pretty standard, right? So, you can kind of reach from a toolkit of, pretty standard models. It doesn't have to be anything fancy even, right? The key thing about each organization is, if you're going to approach this, what you'd want to know is sort of what are the features that are sort of relevant for each kind of prediction I'm making. So if it's an account, what are the features of the account that are relevant, and what's the outcome, right? So if the outcome is, trying to value things accurately, so to predict the actual value, that's one metric. And then the last thing is sort of like, what is the business KPI that you're trying to maximize? Because the model can sometimes, if you don't have those If they're not the same, you can kind of train a model that does one thing really well, but doesn't necessarily provide business value. So I think the key things are, defining the features that you want to use, and those will be pretty standard across organizations, right? You'd think, if you're building an epic scoring algorithm, you'd reach for the sort of the same kinds of features and collect those over time. Same thing about the outcome. You kind of want to know, is this the highest value thing? But then you might want to balance other things. So for example, if you want to take into account timely appeal, you might have sort of aging built into the model, or aging built around the model to handle things like, well, I know this is, doesn't seem as valuable, but it's about to expire, so we should address it now. So that could be outside of the model and helps you understand and sort of maximize whatever KPI at sort of the business level you want. To answer your question, yeah, like the use case is going to be pretty common across different customers. So the key thing is like, what's the data we need? What are we trying to predict? And how does this fit into like our overall goals as an organization? What are the KPIs we're actually tracking and trying to use the model to improve?
And it feels like that should be pretty reportable as well, to see like, I've plugged in this model, I've scored it. I can see a real business use case to say like, we are now collecting X amount more, or we are working X amount, or just because of this came in on day one, here's where we're at day 90 versus like the past 90 days or something like that.
Yeah, so the ideal scenario for this from like a data science perspective, which is a hard ask, is doing an A/B test, right? So you have some folks who, just work how they normally do. You have another set of folks who work strictly based on the recommendations of the model. And then you're able to say, all right, we can compare these two over time and see what sort of the actual impact of the model was, and being able to sort of rank things by that, and whether, it improved over some baseline, let's say like outstanding amount or something like that. But that's a hard, operationally, that's hard to implement sometimes. So it's in some scenarios, you can also just say, all right, everybody's doing it, and we're going to take your, the last month's performance and this month's performance and see, the difference in the differences. So for everybody, how well did everybody improve? But there's always, I have some folks on my team who are incredibly smart people and know, there's lots of tricky things to deal with when you have these different experimental designs. But yeah, it is trackable, and that's the great thing about it. You can actually sit down and design an experiment and run it, and try to quantify how this actually is changing things.
Yeah, I have a question for you. When you think about like an A/B test, like what comes to mind for you? Are you okay with like structuring your staff and like working two different models there, or does that give you like a heart palpitation when when thinking about who you might be assigned that work?
I don't know. The more I think about that from my perspective, like I think what I would probably do is do an A/B test for two different teams, but that do the same work. So I would look at it, here's for my professional billing team, be A, and then maybe my hospital billing team, follow-up team, be B. They're both having to call the same payers. They're both having to review claims the exact same way. They're just different types of claims, right? So, but the methods in processing things are going to be very similar, little slight differences in where they go within the system to get data and information, but the physical workflow would be very similar, and even how they score some of the stuff and the contracts, timeliness and all of that append the exact same way. So I would think I would try to do it that way versus saying, hey, half of my hospital follow-up team is going to do this versus that, because I think that will cause them confusion, especially if they're both working, end up having to cross and touch the same account at some point in time. So
yeah, that's an interesting insight, and in some ways that complicates the experimental design, right? So I totally understand it organizationally, but being able to compare apples to apples is the real goal of that, right? So there you're kind of comparing apples to oranges. So that's actually, that's good to know that's how you think about it. One way you could approach that is to say, let's limit the scope to a smaller team, right? Let's say we're going to go focus on HB because sort of the cash volume is much higher. right? And so if there's, something to be gained, it's going to be bigger there, right? That's one way to approach this, and say, split the team, have some work, one way, have some work, how they have been doing, and that kind of simplifies things. Another way to think about this kind of input is it's sort of like net new information, right? So it's always like, presumably it's going to be a gain, a net gain overall, right? So what's really happening is the whole idea of an A/B test is you're like getting information about how things could work. So in that sense, like the investment of doing this, is kind of an experiment in gathering information about how things could work better. So I think the goal might be to then focus in on operationally, how do you make that easy enough to do? And again, splitting by team directly means you won't get sort of that apples to apples comparison. So ideally, you'd be able to split within a team to kind of understand the true effect of what's of the model.
Mm-hmm. I think hearing that, I think that where I then might apply it is if you have like a governmental team versus a commercial team. Your commercial is going to be your higher dollar, governmental's more controlled in what they can do now. So while you have limited ability to make a lot of changes because of how Medicare and Medicaid operates, you still have the ability to modify your workflows more fluidly and do things. So that might be your control case, is putting it on, if your teams are split between commercial and governmental, is maybe focusing on your governmental, where it's stagnant and the dollars usually just flow through, but you could isolate it down to more of a where the dollars are for those outliers, that the dollars aren't just automatically coming in for you.
Yeah, that's great. I mean, I think that insight of like how to structure things is something that we work really closely with both our internal subject matter experts, but also our customers to figure out, like they have such good insight into how things are structured, how things are working currently. What we're trying to figure out is, how do we work together to identify sort of where we can improve that whole process.
Maybe just thinking about like installing a data model or like getting a data model plugged in. Is there like a large lift for like IT? Like maybe I'm a listener, I'm operations, and I've been looking to explore something like this. Is there like a steps or like conversations that I should be having around my hospital for exploring like getting this set up and rolled out?
Yeah, I think so. This is sort of like one aspect of what Janus is working on. I'd love to talk to sort of more holistically about all the different ways we're using machine learning. But yeah, so that it comes back down to, what are the data sources we need for this? So we're relying on like standard X12, 835s and 837s in the AR follow space, and pretty lightweight EHR extracts to be able to structure that. So that's sort of like getting the data itself, training the model, and then that's sort of done on our side in the cloud, and then being able to get those predictions back into the system of work is sort of, if we're working with Epic, that we've done the most with, it's an Epic integration, so it's a daily file. So it comes back down to getting all the data, making the predictions, and then getting them back in like a CRD or a 277. So that's the general workflow.
What did you just tell us?
It's a bunch of extracts, a bunch of interfaces. We're passing data back and forth.
It's like there's data on the customer side. X12 data is like really easy to work with, right? It's relatively standard. It's a standard. Those files are usually easy to access for customers. We have sort of a lightweight extract, which is just allowing us to kind of pair that with that X12 data, which is easy to access, to build up kind of the history of claims over time, right? So we're trying to focus in on like the most easy to access standard kind of data that we can get, build up a history of claims over time, train a model on that to predict different outcomes. So that includes things like largely focusing on sort of the paid amount for this use case. Being able to then say, okay, we're able to predict this paid amount. We can now say, of all of your outstanding AR, here's sort of the highest, highest value things. This is ranked the highest, work them like this. We have all that data, and then we need to get it back into the system of record. So let's say that's Epic. There are different ways of ingesting that data back into Epic. So there's, CRD files, 277 files. I'm not an Epic expert, but I think I've, by osmosis, I've learned some of this at least. But there's ways of getting that back in. So it really is just about, like, if you want to do this, think about, what data you have access to, and sort of how do you get data back into the system that you need to actually drive the work.
Perfect. Well, let's take a quick break, and then let's dive into how Janus is doing this with their clients.
There are thousands of medical offices and facilities across America, each navigating through changing regulations and reimbursement models while striving for positive patient experiences and outcomes. A common element in each of these facilities is patient access, the front line of both the revenue cycle and the patient experience. Though diverse in facility size and geography, patient access professionals unite around a common purpose: enhancing the overall patient experience to increase patient satisfaction and outcomes. Through it all, one organization is there to educate, connect, inform, and pave the way toward the future of patient access. The National Association of Healthcare Access Management recognizes the changing role of patient access professionals and their increased importance.
We're back. Okay, Chris. So as I cut you off there, if we were diving into some of the items and, talking about what is Janus kind of doing in the machine learning AI space, and then we alluded to some of the internal machine learning there with Epic, like work queue scoring. For instance, how are you, we'd love to learn more about Janus and what types of products and services that you guys are offering to your clients, and how those are then integrating back into, Epic or other EMR systems. And some of that, we know Epic's going to have their own internal version. And then we also know for other EMRs that they might be still in that development phase. So you could be offsetting that for our listeners.
Yeah, so that's a great segue. And so we kind of talked about, work queue prioritization. That's what we're focused on. And that's sort of one application of machine learning that we've worked on. And I kind of want to take a step back and talk a little bit about sort of how does that fit into the bigger picture of what we're trying to accomplish. So in addition to sort of, understanding all of the sort of that's sort of packaged into our claim solution, which is really about getting claim statuses and being able to kind of prioritize work once you know that status. We're largely focused on kind of two other aspects of our platform. One of them is our sort of process intelligence aspect, and I'll kind of get into the details of that. And then the other is sort of our automation platform. And those two combine very nicely together. So I'll get into what process intelligence is and how that feeds into automation. So the real goal is, being able to accurately automate as much of the revenue cycle work as we can, right? That's what we're aiming to do. And importantly, I think one of the folks on our growth team says, take the robot out of the human, which I think is a really nice way of putting it. What we're trying to do is focus in on the things that can be automated, so that revenue cycle workers and operators can really focus on the things that are hard to do, right? Are hard to automate, that require a lot of experience and know-how and are very nuanced. So have them be able to focus on that. So what our process intelligence platform is it's software that is capturing metadata about how people are doing their work. All of that metadata gets ingested through a machine learning pipeline. And when we get out the other end of that is, here's how this user did their work, right? We're aggregating this across many, many differences of the same workflow. So, you got this denial reason from this payer, and we see that, hundreds or thousands of times, understanding how people are doing the work, what variations there are, and ultimately what leads to the best outcome, right? When you take those steps and say, we've gathered a lot of data and we've figured out what the best outcome is, the next thing that feeds into is automation, right? So you say, okay, if you know sort of the path through this whole workflow, there's lots of variation. How do we break that down into steps and translate that into something that can be automated? So that's kind of there's sort of being able to kind of manage what you're currently doing, optimize that, but that fits into sort of, the longer term vision of, finding out what the right way to do work is, and actually making it happen.
Do you, in looking at that automation of work and all in that component, and you're taking different users, then do you retro apply that back to say, okay, here's the algorithm, and while we're learning to build out this machine, here's where you also back to the clients, here's where you have variation of people doing things differently, and we need to, one, figure out how to streamline that, or two, is this meant to be variation because of the type of information that they're collecting?
Yeah, that's an awesome question, and you can kind of think about this in terms of like starting with descriptive kind of statistics, moving to predictive statistics, and then prescriptive, right? There's sort of a staircase to do that. The first point you made, or one of the points you made, is, start off by just showing them how work is currently done. And depending on how you group things, what you might say is, oh, well, there's two paths that are pretty clear for this workflow. And what that could tell you is, people are doing things in very different ways, or there's some other feature of an account that tells you that it goes down one path versus another, right? And showing that to an operator, they might say, oh yeah, it's because if this or this condition is met, you do it one way. If not, this is a standard way. So there, it's about, I think you're exactly right, figuring out the right level of granularity and grouping, and doing that automatically as well. So gathering a lot of data, being able to show this to operators and have them give us input, so we can figure out sort of how to group things, and get the right level of grouping, and then ultimately be able to do that automatically. The step beyond that is, let's say we have the right grouping and we say, yeah, this should all be done the same, we think, and there is variance, or there is variation. Then the question becomes like, is this about, retraining? Do we need to update our SOP, like the standard way of doing things? Just remind people that, this is how this has worked, and get them sort of all doing the same thing. But then the last piece of that too is like, maybe people have discovered a better way of doing this work. And so we actually want to look at, the variation and see, is it tied to differences in outcome, right? Are there trade-offs of, one sort of way of doing this work takes, a lot longer? We can factor in sort of the cost of work, so that sort of the net benefit, in different ways. But ultimately, once you figure that out and say, yeah, we've looked at the data, right? We've looked at these sort of the workflow as a whole. We've identified that this is sort of the right way to group things together. This is the best outcome. Then we can move on to sort of the prescriptive stage, where we're saying we should do this, and let's figure out how to automatically make that happen.
Perfect. What are some of the things that, as you start to engage with a client, are kind of those first checklists that you want them to be able to say, to even see if they're ready for this type of support of bringing in?
Yeah, I mean, I think there's I think almost all operators are really willing to explore how they can do things better. I think that's something that, it's a really hard job, right? There's a lot of complexity, and things change very quickly. And so I think anything and everything that we can do to help folks, get on top of things and stay on top of things, everybody's very receptive to that. And so I think it's really about that, like knowing where there are pain points, but also being able to communicate and help us focus on, where we're capturing this vast amount of data, right? We're kind of trying to distill it down being ready and willing to kind of work through that and kind of figure out, where can we take the next steps to kind of, figure out how to optimize things is really, it's just bringing that willingness. And I think that's something that all of our customers do bring.
Perfect. Where else are you, what other spaces of revenue cycle or healthcare are you guys diving into?
Yeah, so kind of the things I've talked about are largely sort of like the back end of the revenue cycle. So thinking about follow up, what we'd like to be able to do is sort of take this same approach and apply it to throughout the sort of the full revenue cycle. So as much as possible, we're trying to figure out how to do is fix things downstream, but also kind of cascade that back upstream. So if you're getting particular kinds of denials in AR follow-up, you can automate working those, right? But ultimately, what you like to be able to do is figure out why they were denied in the first place, go back up to billing, get those fixed there. Another solution we have, so this is sort of like our claim statusing solution. We have a prior auth solution. So again, that's sort of further upstream in the process. But again, the goal is building out the same set of tools, being able to capture a lot of rich data, get more out of it, understand the patterns of how work is being done, and that same kind of like tool set can be applied in sort of throughout the revenue cycle. We haven't done anything sort of outside of the revenue cycle. We've largely been focused on honing and kind of refining that process in a particular area. So that's kind of been our focus to date.
Okay.
And what would that look like, for example, like in a prior auth, like that almost feels a little bit real time to me. Like I'm in the moment, versus like a follow-up. It's like I have all the data there. It's something that like somebody's looking at in a work queue or work post, whatever they're doing. And maybe isn't a time urgency versus like if I'm getting a prior auth that might be a little bit more real time, a little bit more urgent.
Yeah.
How does the flexibility of a model like precipitate between like a real-time situation versus a non-real-time situation?
Yeah, that's a really good question. I think you hit the nail on the head. There's like very different paradigms of, let's say getting a claim status is not, urgent. You want to be able to do it at sort of like at the right time, kind of on a schedule. So let's say like every week or every 2 weeks or something like that. When you're, doing prior auth, it's a user-driven kind of workflow, right? They click a button and they expect a response, and there have to be kind of requirements there. For that, it is a different paradigm, right? So we're figuring out optimal workflows independently of the actual sort of like implementation and use of those. So in both those scenarios, there isn't necessarily a conflict. If you've sort of created an automation that performs, the prior auth workflow, you can basically kind of hook that up to a user request in real time, right? So it doesn't have to go through like a larger sort of a larger pipeline or process for that to be possible. That's a really good question because you're not gonna say we'll get back to you next week about this prior auth request. We have to have the actual the response in not real time, but in some reasonable kind of time frame. Yeah.
And then just a question, we mentioned or alluded to this in the beginning, but like generative AI, what is that and how is that different than like the automation versus like the predictability, scoring, and ranking that we've talked about so far?
Yeah. So I'll kind of come at this from sort of the perspective of recent developments, and particularly focused on large language models, which is sort of, if you guys have seen GPT or have sort of checked out ChatGPT, a lot of cool things to do with that. If you haven't, I would very highly recommend it. But the basic paradigm of that is you you take, a ton of text data and you're training a model to kind of fill in the blank, right? So you have, a paragraph or a sentence, and you're training a model to say like, what word comes next, right? So if you do this over massive amounts of data with a really big model, what you end up with sort of is a model that has learned a lot of the properties of language, which is kind of a crazy thing, but kind of a really cool fact. If you do this with enough data, what you can then start to do is to ask it to output certain responses to certain kinds of questions. This is specifically focused on languages and output. There's kind of parallels to this that have happened with images too. But the idea here is you have a prompt that you provide, and you get a response. So if you say, something like, write me a plan or write me a poem. I think these are some of the funnest ones, are like, write me a poem about the revenue cycle or something like that. It will generate things that are, about the revenue cycle and are actually, not terrible. Folks on my team have had some fun doing that and kind of come up with some funny poems. But the basic idea is that what you're getting is sort of like an open-ended response to a prompt, right? It's generating this response based on your input and the properties it's learned from a lot of data. So this kind of comes to a question of like, how can we use this, or where is it appropriate to use this? So one of the challenges of using sort of these kinds of models and these approaches is it can depend on the domain you're trying to apply it to. So in a lot of instances, when you're trying to, let's say generate like ad content or marketing stuff, it's open-ended and you can generate things. And if it's approximately right, that's great, right? There's no sort of like hard and fast categorical, this is correct or not. It's a gradient, right? In scenarios where you're trying to, let's say, like automate things, it becomes a little bit more complicated, right? So especially when there are sort of systems that have, outside consequences, you want to be very careful and mindful about generating actions or having effects in systems that are sort of unintended. So there's kind of there's one sort of general, like, I think, cautionary tale of, make sure to understand the domain of the output, whether there's a human in the loop that can kind of correct things if they're wrong, and also make sure that sort of the potential external consequences are kind of limited in scope. I do think that there are still great applications if you can sort of build a system that has those kinds of guardrails into it.
I'm trying to think about like where this would sit in like revenue cycle specifically. Like maybe I'm like typing out a letter to a payer, like it could automate like some of that information, or like craft my response, or like if I'm responding to a patient for some sort of inquiry, I could do it there. Like I don't want to like get into like, I don't know how much you can disclose about what you all are doing, but where does like Janus sit or exploring that type of work?
Yeah, so I think there's kind of like a metaphor we use in sort of all of that process data that we're gathering. We're kind of, and I won't go into too many more details, but we're kind of like treating that as like the language of the revenue cycle. So when you adopt that mindset, or that kind of lens of looking at the data, there's lots of ways to apply those same techniques to that data. But coming back to your question of like, where could we apply this? Like you're exactly right. Where there's text that needs to be generated, that's like a perfect opportunity for that. There's also actually a reasonable amount of text that can be extracted from, or sort of information can be extracted from text using these kinds of models. There we have kind of the same difficulty of making sure that, it's very precise, right? So if we get a letter and we say, let's pull out the patient name and the date of birth, the date of service, sometimes it may get it wrong, right? Other systems or other kinds of models may be more reliable or easier to kind of train to do the thing we want if they're purpose built for that. But at the same time, these like very large and really interesting and impressive models can do similar things to that. So it's the same kind of question of like, or the point I made earlier of saying, if you're going to use things, make sure there are guardrails in place, make sure there's a human in the loop to continually validate that it's getting the right thing. It's basically you need monitoring, right? So I think the bigger picture is we're still figuring out like all the different ways you can use this. But yeah, like text is a really great area if you have a lot of free form text, especially if it's not structured in a nice way. That's a great application for these. But I think I very much recommend that people get an account with OpenAI. Don't put any PHI in there, but just like play around with it, like use it for certain things. And I think the more people like interact with these tools, the more ideas that will come. One of the best things about what we're working on is that sort of the sky's the limit. It's really about like how you can be creative and apply these tools to solve problems. So there's a ton of work to do. If you start with these areas where we think we're gonna where there's text, great application for it. But the more use cases we can come up with, the better.
All right. Well, on that note, we're going to take a quick break and we'll be right back.
Claim Capital is a team of ex-Epic staff focused on preventing denials. Instead of showing what was denied, which is the standard for other solutions available today, Claim Capital pinpoints why claims are denied. By training machine learning models on an organization's claim and remittance data, Claim Capital can identify the causes of denials and recommend changes in EHR build or workflows to prevent them from happening in the future. With a completely HIPAA-compliant infrastructure, no software implementations, and a zero-risk pricing structure, organizations can quickly and safely recover lost revenue.
And we're back.
Just as we're wrapping up, Chris, just want to like talk through like pitfalls or maybe like various learnings that you just like want to like caution folks when they're like rolling this out. I know it can be a big effort. It can be maybe not scary per se, but you're kind of handing off the keys a little bit to some sort of automation, some sort of tool to supplement your work. Just anything you want to like leave our listeners with, just make sure that if they're having these conversations, and if it isn't with you, like what types of things should they be like, this person's not saying the right thing?
Yeah. So there's always the risk of models hallucinating. And so this is when they're confidently telling you the wrong thing, but very confidently. So one example I mentioned to you guys was somebody asking, it was either ChatGPT or Bing about, how many N's are in the word mayonnaise. And it's saying very confidently, 1. Then, follow-up was, are you sure? Here's a link to Webster and saying, yes, there's 1 N in there. And even responding, like, yes, mayonnaise with two N's has 1 N in it. So there's risks of sort of the model just being wrong. So I think as things start to mature, it's easy to build sort of like cool proof of concept demos. Building larger scale like products and or systems that are reliable and safe is actually a big engineering undertaking. So I think that's where most of the challenge lies. And I think what you really want to look out for is an understanding of what the actual sort of use case is, right? Not we've got a big hammer, but not everything is a nail. Sometimes smaller or simpler systems will do better and meet your use case. So start by doing things simply, right? So people call just simple keyword matching AI, right? I mean, if it does the trick, start with something simple and kind of escalate in terms of things as needed. Other things to kind of look out for is whether there are humans in the loop, right? So it's especially important for in healthcare to know kind of have guardrails and or kind of systems that allow people to intervene where it's needed. So I think having a very clear idea of the system, not just, we're going to send all this information to an API and get back some magical response. There has to be some kind of guardrails and sort of systems around that to make sort of keep track of, how it's performing, when there are exceptions, things like that. And the last thing I think, especially for healthcare, to think about, be very careful about sending PHI anywhere, right? So for any of these kinds of models, there are now open source models that can be used for different purposes and self-hosted. So those are probably the sort of longer term, those are potentially solutions to this kind of problem or tools to use for this problem. So all of those kind of considerations of, when people are talking about this, make sure they understand it's not magic, right? Sometimes, simple tools we have already work and can be used. It's more about systems than just a single model, and where those models live, whether it's sort of an API you're accessing, so it's somebody else's model versus your own and you're hosting it, and can kind of know sort of that everything is HIPAA compliant. Those are all key things to kind of keep in mind.
Is just one last question? What is one area that you would recommend revenue cycle leaders or revenue cycle and their IT teams to start to think about if they've not already started playing with some form of AI and machine learning? Where would you recommend them maybe get their feet wet?
Oh, I mean, I think like getting your feet wet, I think especially around anything that has a lot of text, right? And there's tons of different areas. So like, correspondence coming in, that's a huge area that you could apply this. Again, like I think the approach should be, if we're trying to solve a problem, do we have simpler solutions first? Kind of like from a building a system, what's the simplest solution that would meet our need? But if it doesn't, anywhere where there's a lot of text that is we want to get things out of or to generate are areas where people can get their feet wet for sure.
Perfect.
Right. I think we've done a pretty good job today. That was I learned a lot. Thanks, Chris, for joining us here. I know I see headlines about this stuff every day, and it's like, how does it apply to healthcare? How does it apply to what we do every day? And I don't see those headlines as often. So I appreciate you taking the time here. If as we're thinking about like next steps, like folks wanting to like connect, I know our listeners like know how to reach Evan and I, but Chris, is there a best way for folks that they're like exploring this, want to talk to you, want to talk to Janus?
If you like today's episode, continue to join Wilshire Wednesdays.
Yeah,
You can follow us on LinkedIn
email,
or Twitter at Evan_Wilshire. Daniel can be followed at
way, or
Daniel_TWG.
via
Wilshire Group
Chris
at
at
TWG Health. On Facebook at the Wilshire Group, or on Instagram at
and
Wilshire IT
LinkedIn,
Revcast.
I'm
Remember,
motivating
if you prefer to
my
watch,
reserves,
come check us out at the Wilshire IT
but I'm the
Revcast
only one at
YouTube
Janus,
channel.
so
If you have an
folks don't find me
inquiry,
that
want to
way,
share your thoughts,
they
or get
can,
additional
for sure.
information on today's episode, email us at WilshirePodcast
Perfect.
at
Thank you again,
thewilshiregroup.net.
Chris.
The best
Thanks,
way to
Daniel,
support this
for
podcast is
more
to review,
information. I
rate,
sure
and
learned
subscribe.
way
See you
more
next
than
time.
I ever
Bye-bye.
The Wilshire IT
This
Revcast
was
is
an
hosted,
interesting
produced,
episode
and
for me. I'm
engineered by
usually
Evan
the talker
Martin
in this
and
type of
Daniel
video. That's
Bianchini.
the lead.
It is
So,
executive produced by Gretchen Case,
well,
Hank
it was a
Smither,
pleasure,
and Spencer
and
Thielman. The Wilshire Group.
once again,
Experience you can
everybody,
trust,
check us
results
out
you can
on
count on.
YouTube as well. If and submit those questions. We're not able to get to the Wilshire Lab today, but please submit questions in future. That's it. Have a great day. Bye-bye.